We're looking at section 10.3, and we're going to be graphing cube root functions. So the cube root parent function is f of x equals the cube root of x. So to choose to graph f of x, choose values of x and corresponding values of y. And we can choose both negative and positive values of x. We don't have to limit ourselves this time with the domain and range because we can have negatives under the under the cube root. So the cube root of -8 is -2. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. So then we can graph those points of -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. Now you'll notice, I'm not very good at graphing this one, but it's actually very similar to our cubed function, just kind of rotated 90 degrees. So domain and range for both of these will be all real numbers. We don't have any issues here because we can have that negative under the square root. So does this graph have any symmetry? It has what's called point symmetry. So it's symmetric about the point. In this case, it's symmetric about the point 0, 0. That's going to come into play later because that's where we're going to be looking at on our graph. That's the point we're looking for when we want to see how the graph is shifting. So can the radicand in a cube root function be negative? Yes, that's what's under the square root. It can, in fact, be negative because the cube root of a negative number is a negative number. So these transformations are acting the same way as all of our other ones are. Anything outside the cube root will shift up or down. Anything under the cube root will move left or right. Vertical stretch or compression, multiplying by a number bigger than 1 will be a stretch. Multiplying by a fraction is a compression. And then reflection, if you multiply by a negative, it's across the x-axis. The only one we're dealing with here. So again, the important point is looking for that point of symmetry. Usually it's at 0, 0. So, use the values of a, h, and k to draw the graph. And then, so we're looking at how the y values are changing again. The x values should change by 1. And then the y values, how those are changing is telling us our vertical shift that we're looking for. So in example A here, we want to graph this transformation. So we can see they're multiplying by 2, so that's a vertical stretch of 2. Under the square root, we're subtracting 3, which means we're moving to the right backwards in our head, 3, and then 5 units up from outside. So again, it's always helpful for me to see how those changes are affecting the points. So our x values, we'd have to add 3 to move to the right. Y values, we'd multiply by 2 and then add 5. So these are the reference points that we like to use to find the new coordinates on your graph. So let's look at this one instead. We've changed a little bit so we don't have the horizontal aspect. So in this case, we're going to have a translation 10 units to the right and 4 units up. So seeing how those points are going to change, going 10 units to the right, so we'll have to add 10, and then 4 units up, so we will add 4 there. So plugging in those values, -8 plus 10 is 2, -2 plus 4 is 2. -1 plus 10 is 9, -1 plus 4 is 3. 0 plus 10 is 10, 0 plus 4 is 4, and then 11, 5, and 18, 6. You can graph those on your own. So let's look at this one. So what's happening here? We've got a -3 under the square root. That means we're going to have a right shift. So it would be x plus 3. And then the plus 6 on the outside is a vertical shift, so it would be y plus 6. So putting in our values, -8 plus 3 is -5, -2 plus 6 is 4. -1 plus 3 is 2, -1 plus 6 is 5. Then we get 0, 6, 4, 7, and 11, 8, and then you can graph it on your own. Now, writing cube root functions. Again, the key thing you're looking for is that point symmetry, finding out where the concavity changes. See how it's concave up and then changes to concave down. So you're looking for that point where it changes. That's your point symmetry. Once you find that, then you can see how the y values are changing, if they're increasing or decreasing, and that's going to give you your a value, how they're changing. So just looking at number 3 here, we have to find that HK point. So that point symmetry point, which is where the shape changes. So that's going to be right here. That point is at -2, -5. So then we can compare the point right next to it, because it's 1 away. So that point is at -1, -3. So the y values are increasing by 2. So that means we're going to have a vertical stretch of 2. So then our function will be 2 times the cube root x plus 2 because of the left shift under the cube root, and then -5 for the downshift.